Welcome to this presentation of Inka V-Link. My name is Michael Vogel. I'm a Senior Product Manager at ETAS. Inka V-Link provides a one-click built environment for measurement, calibration and diagnostics on Windows. It is a Simulink block set for the easy instrumentation of Simulink models to have access with Inka. Inka V-Link does not simply autocode the Simulink control function. It embeds automotive excellence. The generated control is executed in an automotive typical shell. It runs equipped with an RTA operating system, provides capabilities such as measurement data files for stimulation, and it automatically includes an XCP protocol layer. Inka V-Link is very easy to use for the Simulink user. Details such as A2L generation, protocol configuration take place in the background. It provides for fast simulation. The objects generated are adjustable in execution performance from real-time to the maximum of the PC. The simulation objects generated by Inka V-Link are ready to use for Inka or any other calibration tool. No Simulink license or the model code is required for simulation on the PC. If Inka users do own a Simulink license or need to modify the Simulink model during the exploration, then you should consider using Inka SIP. Let me briefly elaborate on the differences of Inka SIP and Inka V-Link. There is a webinar available for Inka SIP for those who are not familiar with the details of the product. Both products have very similar capabilities, but they are designed for very different use cases. Inka SIP is built for use cases where the Inka user has a Simulink license available and owns the Simulink models. So a typical user of Inka SIP is most likely a function developer. Inka V-Link is built for use cases where the Inka user does not own a Simulink license or where the model source code is not available for the Inka community. In such a deployment scenario, Inka V-Link can be used by the community who owns the models and the Simulink license to generate objects which can be used by Inka users without requiring a Simulink license or the model source code. So this is typically a scenario where function development uses Inka V-Link to make the functionality of a control available to a community of Inka users. Now let's take a look at the product. I'm using the same model that I had been using for the Inka SIP demo. In order to generate an object with Inka V-Link, I need to set the code generation options. Inka V-Link provides an ETAS code generator that embeds automotive excellence in the generated objects. In addition to the code generator, several blocks become available natively in Simulink to enable the function developer to orchestrate the simulation of the control function. A series of blocks allows to schedule certain subsystems in time rasters. These blocks can be used, but they don't have to be used. If no blocks are used, the model is executed with the default Simulink time raster. There are various other blocks available, for instance to add measurement data files and route measurement signals to specific model ports, or other blocks that help to set up Inca experiments. However, these blocks are optional and don't have to be applied. Once all desired features are added to the model, it is simply required to start the code generation. As you could see, for this presentation, I was simply changing the code generator to ETAS vLink. The build process now generates an A2L file describing the calibrations and signals of the simulation object, as well as a COD file. The COD file is very similar to a PCDLL. It holds the model as a code file for Windows execution. The model also includes all the necessary infrastructure so that it can be easily executed with Inca. As I was saying in the beginning, Inca vLink helps to secure the intellectual property contained in a Simulink model and still enables business partners to simulate the control in a PC environment. So at the end of the presentation, I simply need to send the A2L file and the COD file to my business partner to enable him to simulate the control. Now I'm changing my role in this presentation. I am no longer a user with the Simulink license and the intellectual property contained in the model. Now I am a business partner who needs to explore the control for my new engine system. I had been receiving the A2L file and the COD file from my supplier and detached them to my local drive. Now I'm using Inca to configure my simulation very much alike to working with a real ECU. I create an Inca project and assign the A2L file to it, and I create an Inca workspace. As I will be not connecting to a real ECU, I pick the PC simulation target as my ECU. I pick the x86 controller and assign the A2L file to the simulation. When I double-click on the workspace to connect to my simulation system, Inca automatically loads the COD file into the simulation environment and opens a new experiment. At the top corner, additional controls become available to start and stop the simulation. Now let's take a brief look at the VRTA execution environment. It becomes available in the Windows system tray. It allows the Inca user to change the simulation performance from scaled mode to adaptive timing. Scaled mode executes the control basically like in real time, of course with all the constraints of the Windows operating system, whereas adaptive timing maximizes the execution performance of the control by eliminating all idle times of the operating system. Now let's set up the experiment. Inca variable selection dialog shows all calibrations and signals from the Simulink model. The Simulink model contains a control model, a simple PID controller, as well as a plant model from the mechanics of the throttle control. In addition, it includes stimuli generators. All this is included in the simulation object. Let's pick the actual position and the desired position, as well as the PID parameters, and set up the experiment. Once the experiment is set up, we can start measuring. Let's zoom to fit, and we see the control simulated in scaled time. Let's change a calibration, and we immediately observe a change in the PID response. And all this without having a Simulink license. Now let's go back to the VRTA execution environment and change the simulation performance from scaled to adaptive. And immediately the simulation runs as fast as possible, faster than the webcam can actually capture the performance. Let me summarize at the end of the presentation. Inca VLink allows to separate from Simulink users with the models to Inca users without license and without model, still being able to simulate the control in a PC environment and apply measurement and calibration. Inca VLink is a one-click build environment with real RTW code generation. In addition, it provides RTA operating system support, XCP protocol stimulation, and measurement data file as signal stimuli. It allows an easy instrumentation of Simulink models for Inca, enables a simple distribution of control functions to non-Simulink users, and provide a true automotive execution environment. The Inca community, on the other side, is capable of having control functions in a PC environment. Measurement data files are not tied to the simulation object. Inca users can still use their own measurement data files and can access the object via Inca EIP or XCP communication protocol. Inca users can use their familiar experiment environment to prototype functions in a virtual environment. They can use the fast simulation capabilities of the PC and do not require a Simulink license or the model. I hope you enjoyed the presentation. Thank you very much for joining in. If you require any additional information on Inca SIP, Inca VLink, or the ETAS solutions for Simulink, please contact ETAS or visit our website. Thank you very much.